regression and the basics of logistic regression and machine learning. First of all, let's get started to machine learning types. Machine learning has three types: supervised learning, unsupervised learning, and reinforcement learning. The supervised learning is a model training with labeled data. It has classification and regression. And unsupervised learning is model training with unlabeled data. It has aspects like clustering and association. And reinforcement learning, it's mainly based on environment and model agent. It takes action in the environment and receives state updates and feedbacks. The difference between supervised learning and unsupervised learning is that it shows in the picture that the robot is shown asking banana while looking at 3 apples. The human responds no and holds up a picture of apples, to which the robot finally responds with apple, and the human says yes. This illustrates supervised learning, where the robot learns with the help of labeled data. In supervised learning, the model given inputs and the corresponding correct outputs. The model learns to predict and the correct label after being trained. On the other side, the robot seems confused looking at a mix of apples and bananas, saying this are one thing, this is something else, is this right, with crickets chirping in the background implying uncertainty. This represents unsupervised learning, where the robot is given a data set without labels or guidance. It tries to find patterns and group similar items together on its own without knowing the correct categories beforehand. In this case, the robot groups apples and bananas into different classes, but it isn't sure if it did right because there is no explicit feedback. Logistic regression is in this classification. In the supervised learning, even though the logistic regression is called regression, it's not used mainly for classification. Logistic regression is used for binary classification, and where we use sigmoid function that takes input as independent variables, produces a probability value between 0 and 1. For example, we have two classes, class 0 and class 1. If the value of the logistic function for an output is greater than 0.5, then it belongs to class 1, otherwise it belongs to class 0. It's referred to as a regression because it is the extension of linear regression, but it is mainly used for classification problems. Binary classification example, we can see it in the pictures. It's logistic regression is ideal here because the output heart disease risk is binary. Either the patient has a high risk of a heart disease or not, class 0. The input feature is in age. As people age, the probability of developing heart disease tends to increase, and the logistic regression curve, which is S-shaped, shows the predicted probability of having heart disease on the y-axis at the age of the patient on the x-axis. For younger patients, the probability of heart disease is low, of course, and as the patient's age increases, the curve rises, indicating a higher probability of heart disease. So, between linear regression and logistic regression, we have to say differences and similarities. Linear regression is the simplest form of regression, assuming a linear relationship between the input and the output variable. In simple terms, it harnesses the power of a straight line. The equation for a simple linear regression can be as y equals mx plus b, where y is dependent variable, x is independent variable, and m is the slope, and b is the intercept. On the other hand, the logistic regression is a powerful supervised machine learning technique. It helps categorize outcomes into two groups by assuming a linear relationship between the two features in the outcome and then calculating the possibility that the outcome will fall onto the group of the other. Well, it's mostly in probability of success of the y categorical variable and yeah. So the similarities between linear regression and logistic regression is linear relationship. Both of them assume a linear relationship between the input, the features, and the output, and both are supervised machine learning algorithms. And both algorithms have similar limitations, including non-linear relationship between input and output variables, and unclean data and missing values will lead to poor model performance, and both models are prone to overfitting, which reduces the use of a feature selection. And second, differences. First, output type. Linear regression predicts continuous output, and logistic regression predicts probabilities for binary class. And equation and activation function. Linear regression uses a simple linear equation, while logistic regression uses logistic function, and loss function. Linear regression minimizes the sum of squared differences, while logistic regression minimizes the logistic loss. And type of supervised learning, linear regression is a regression model, and logistic regression is a classification model. And the example of a logistic regression and a linear regression. First, we predicted whether the student passed or failed based on the hours studied. The model predicts whether a student who studied for more than 4.5 hours will pass. The S-shaped curve shows the probability of passing as study hours increase. And simple example of linear regression is marks of student based on the hours they studied. If a student scores 85 marks, the model predicts how many hours they likely studied based on this linear relationship. The regression line shows the trend, and the scatter plot shows actual data points. And lastly, application of logistic regression. We use logistic regression to predict the likelihood of a patient having a certain disease or condition based on the symptoms and medical history, and models of logistic regression can analyze an individual's credit history and other facts to determine the probability of them defaulting on a loan. And it can be used in fraud detection system to identify suspicious transactions or activities based on various indicators, and it can predict the likelihood of a customer leaving a service of subscription based on the usage patterns and other factors. That's all.